This is second lecture of third chapter, metals and non-metals of subject science class 10th. I will discuss in this lecture about chemical properties of the metals. In chemical properties, I will discuss reactions of number 1, metals with atmospheric oxygen. Number 2, metal oxides with water. Number 3, metals with water. Number 4, metals with acids. And at number 5, metals with other salt solutions. First, let us do an experiment to find out what is the difference in oxides of metals and non-metals. In this experiment, I burn sulfur and magnesium. You can identify that here this is a metal piece, which is magnesium, and this is non-metal. It is sulfur. First, I burn magnesium. I dissolve this burnt magnesium in water and test it with litmus paper. You can see that it turns red litmus blue, means this is basic in nature. You can conclude that metal oxides, when dissolved in water, they turn into base. Next, I burn sulfur and collect the burnt fumes here. Now I test this solution. You can see that this solution turns blue litmus red. That means this is acidic solution. It means non-metal oxides form acids when dissolved in water, or non-metal oxides are acidic in nature. Most metal oxides on being dissolved in water produce bases like magnesium. Most of non-metal oxides on dissolving in water form acids. Now I start burning of metals in air. I am going to burn aluminium, copper, Fe or iron, Pb or lead, Mg, magnesium, Zn, zinc and Na or sodium. And I will note down the color of the flame produced and the burning ease, and last the solubility of the oxide formed in water. First, you see here this is aluminium piece. On putting the flame, it melts and only the surface coating of oxide is formed. So it doesn't burn so easily in ordinary flame. The second reaction, I try to carry out that burning of copper. This is copper piece. I put it in flame. You can see that it doesn't burn. Instead, on the surface, a black coating is formed. This is copper oxide. This copper oxide doesn't dissolve in water. You can see here in this test tube. Next, I try to burn this iron. This is iron piece. On heating, its surface turns brown. This is iron oxide formed. Iron also doesn't burn. And this iron oxide also insoluble in water. Next, this is lead piece. Lead is metal, and on putting this piece in the flame, it also melts down with a formation of layer of the oxide. Next, I take this magnesium piece. On putting in flame, it burns with dazzling white light, and the oxide formed is soluble in water, and it is basic, as I have already shown you. Next, this is zinc piece. This zinc metal on putting in flame also melts, and a surface coating is formed, that is of zinc oxide. Zinc oxide is sparingly soluble in water. Next, this is sodium. On putting in flame, it burns explosively and the flame is yellow, and the oxide formed on dissolving in water forms sodium hydroxide, that is a strong base. All metals don't react with oxygen at the same rate, neither the reaction starts at the same temperature. Sodium and potassium react too vigorously. Here you can see in the periodic table that what metals react vigorously. These are the first and second group metals. Even if they are left in air for some time, they may catch fire. They are so reactive, these first group metals. This is why they are kept immersed in kerosene. Aluminium, magnesium, zinc and lead are covered with impervious oxide coating that prevents them from further reaction with the oxygen. Iron does not burn in bulk in ordinary fires, but its fine feelings. But in finely divided state, iron burns in fire too. Most of the metal oxides are basic in nature, but some oxides show properties of both acids as well as bases. Means they react with acids as well as bases. Such substances that react with both acids and bases are called amphoteric. For example, aluminium oxide or Al2O3 reacts with HCl to form aluminium trichloride and water. And aluminium oxide also reacts with NaOH to produce NaAlO2 or sodium aluminate plus water. Most of the metal oxides are insoluble in water, but first and second group metal oxides are water soluble and react to produce alkalis. The reaction is for the sodium oxide Na2O plus H2O produce NaOH or sodium hydroxide, and the reaction of potassium oxide is that is K2O plus H2O produce KOH or potassium hydroxide. Next, at point number 2, we study reaction of metals with steam and water. Some metals, the reactive metals of first group and second group, they react with cold water. And all the metals that are above hydrogen in the reactivity series can only displace hydrogen from water or acids. And no metal which lies below hydrogen in the reactivity series can displace hydrogen from water or acids. First group metals are above hydrogen in reactivity series. Many of them, like sodium and potassium, react with water at room temperature very vigorously. You see the reaction of sodium with water here. It is so exothermic and vigorous that the hydrogen evolved catches fire. First and second group metals, as I have told you, react with cold water. The reaction of sodium is written as Na plus H2O produce NaOH plus H2, and similarly K plus H2O produce KOH plus H2. Calcium reacts with cold water but not so vigorously. The reaction is Ca plus H2O produce CaOH2 plus H2. Mg reacts with hot water, and the reaction is Mg plus H2O produce MgOH2 plus H2. Aluminium, iron and zinc react with steam in the pure state, but impure aluminium and zinc react with hot water too. You can see here. This is zinc. It reacts with hot water to form zinc oxide and hydrogen is evolved. And next, this is aluminium. You can see here, on heating water, this aluminium also reacts with water to produce aluminium oxide and hydrogen is evolved. Next is iron. Iron doesn't react with hot water. Instead, it reacts with steam, and the reaction is Fe plus H2O produce Fe3O4 plus H2. Next, at point number 3, we discuss the reactions of metals with acids. I take 4 test tubes numbered as 1, 2, 3 and 4. I put dilute HCl in all and put magnesium in 1, aluminium in 2, zinc in 3 and Fe in 4. You see the rate of reactions. The fastest reaction is that of Mg plus HCl, and then it is aluminium and HCl, and after that zinc and HCl, and after that Fe plus HCl. Means Fe plus HCl is the slowest reaction and Mg plus HCl is the fastest out of these 4 reactions. And the reactions are: magnesium reacts with hydrochloric acid to produce magnesium chloride, which is a salt, and hydrogen, which is a gas. Aluminium also reacts with HCl to form aluminium chloride and hydrogen is evolved. Zinc also reacts to produce zinc chloride, which is also a salt, and hydrogen is evolved, and Fe also reacts with HCl to produce ferrous chloride and hydrogen is evolved. That means the metals, they react with the acids and salt and hydrogen is formed. It means the metals react with the acids to form salt and hydrogen. And next I discuss that how do the metals react with metal salt solutions. Here is copper sulfate in test tube 1 and iron sulfate in test tube number 2. Here I take an iron nail and put it in test tube number 1 containing copper sulfate, and I put copper metal in this another test tube that contains FeSO4 or ferrous sulfate solution. I leave it for 15 minutes. Now you can see the color of copper sulfate solution in which I put iron nail. It has changed from blue to brown, but the color of FeSO4 is same. I take the nail out. You can see that on this iron nail copper has been deposited. Means the iron has displaced copper from the copper sulfate. But on this copper metal piece that was put in the ferrous sulfate solution, you can see that it is still shiny and nothing has happened with it. That means copper cannot displace iron from iron sulfate. In such displacement reactions, more reactive metals displace less reactive metals, but not the vice versa. In the end, I tell you in brief what I taught you in this lecture. Number 1, we discussed that their reactive metals burn in air to form oxides, and these are basic in nature. Number 2, reactive metal oxides like first and second group metal oxides on dissolving in water for alkalis. Alkalis are the bases that are water soluble. Non-metal oxides like oxides of sulfur, nitrogen and phosphorus for acidic oxides. And when these oxides are dissolved in water, they form acids. So don't inhale SO2 or NO2 because these are highly corrosive. Next, at point number 3, we discussed that reactive metals react with cold water or hot water, and less reactive metals react with steam to form oxide and to evolve hydrogen. And the metals, those lie below hydrogen in the reactivity series, do not react with water. Next, at number 4, we discussed that metals react with acids to form salts and hydrogen is evolved. And in the end, we explained through the activity that the more reactive metals displace less reactive metals from the salt. This was the second lecture of chapter 3rd, metals and non-metals. This chapter is to be continued in 3rd lecture. Till then, goodbye.